This lesson deals with writing names and formulas for binary ionic compounds. To review, when writing a formula, a couple things we need to remember. First, formulas will be made of symbols for the element and subscripts indicating the number of atoms. The more metallic element must always be written first. So if an element on the periodic table is further left, it would be considered more metallic, or if it's in the same group, if it's further down, it would be more metallic. That's because the further down it is, the further its valence electrons are from the nucleus, and thus they would be easier to be lost. And a reminder, a metal wants to lose electrons. So if we look at the formulas, MgCl2, magnesium is further left than chlorine in period 3, so it comes first. Also, it's simply a metal to the left of the staircase, chlorine to the right, another reason for the metal going first. Carbon dioxide is made of two nonmetals. Now when I look at carbon, atomic number 6, oxygen 8, they're in the same period. Carbon is further left, hence it goes first in the formula. Xenon hexafluoride, the FeF6, I see that xenon atomic number 54 and fluorine atomic number 9. When I compare them, the fact that xenon is further down in a group is more significant than who is further left. So xenon is more metallic-like and goes first in my formula. The other rule we must follow when writing a chemical formula for ionic compounds is that the sum of the charges is going to add up to 0. That's because as a compound it is neutral overall. So, what do we mean by a binary ionic compound? Binary means 2, so it is a compound made of two different ions, a cation and an anion, so we're going to have a metal and a nonmetal in the compound. For writing the name, we would name the cation metal first, followed by the anion name. Since it is now a compound, we will drop the word ion that we had used when naming the cation alone and the anion alone. So for example, CS2S. The metal is first in the formula, the cesium, following our first rule. Where does the subscript come from? Cesium is in group 1, a +1 charge, sulfur in group 16, a -2 charge, and so I need 2 cesiums to balance the 1 sulfur in order to have an overall charge of 0. So my subscript 2 is indicating the 2 cesium atoms. Mgs, magnesium is a +2, sulfur a -2. They balance each other or cancel each other so that I only need 1 atom of each. When naming it, I say magnesium for my group 2 metal. Sulfur is a nonmetal, so I need to use the IDE ending for the anion, and I have magnesium sulfide. Try K3P. I find potassium in group 1, so it would just be named potassium. Phosphorus in group 15, nonmetal, so I need the IDE ending, so the name would be potassium phosphide. The 3 comes from the fact that potassium is a +1 oxidation number. I would need 3 potassium ions to balance the 1 phosphide with the -3 charge. Calcium iodide. Try writing the formula for that. I start with my cation. Calcium is in group 2, symbol Ca. It has a +2 charge. Iodide, the IDE ending tells me it's a nonmetal. I look on the nonmetal side of the periodic table, see that the iodide is for iodine, symbol I, has a charge of -1 since it's in group 17. To balance this, I would need an additional iodide ion so that my total anions would add up to a -2 to balance the calcium of a +2. So I would add a 2 for a subscript, and my formula would be CaI2. What about CuCl2? I see that my metal is a transition metal, so my name is going to need a Roman numeral. That would be copper Roman numeral 2 chloride. The Roman numeral tells me that the ion is a +2 charge for copper, and chloride is in group 17, so a -1. I would need 2 chloride ions, hence the formula CuCl2. CuCl, name would be copper Roman numeral 1 chloride. I have the Roman numeral 1 telling me copper is a +1 charge, chloride always a -1, so the formula is just CuCl. Notice CuCl2 and CuCl are different formulas, hence they must have different names. The Roman numeral is extremely important. The subscripts balance the charges. So how do I go about predicting the oxidation number from the formula in order to get the proper name? Let's use Fe2O3 as our example. So get in the habit of finding the first element in a formula on the periodic table. I find iron, atomic number 26, is in transition metal in Roman numeral land. So I know that my name is going to be iron, some Roman numeral, oxide, IDE ending for my nonmetal anion. So I'm going to start with my anion to help me figure out the Roman numeral or charge of the iron. Oxygen is always a -2, so I have 3 of them for a total of -6 for my anions. That has to be balanced by 2 iron cations. I know there's 2 from the subscript with the Fe. That has to add up to a +6. The only possibility would be for each cation to be a +3 charge. The Roman numeral equals my charge, and so that is the Roman numeral that goes in our name, and we have iron, Roman numeral 3, oxide. Let's try another one, FeCl3. Chlorine is in group 17. There's 3 of them in the formula, so my anions add up to -3. The cations must add up to a +3. There's only 1 in the formula, so iron must have a charge of +3, and its name would be iron, Roman numeral 3, chloride. PbCl4. Find Pb on the periodic table. Atomic number 82. A reminder that Roman numeral land includes the elements in the metal area that go up to the staircase once we have hit transition part of the periodic table. So again, start with your anion to figure out the charge. Chlorides add up to a -4 because I have 4 of them. There's only 1 lead. Lead must have a +4 charge, so my name would be lead, Roman numeral 4, chloride. A reminder, the Roman numeral equals the charge, not the subscript. One more, Cr3N2. 2 nitrogens, I look at nitrogen, it's in group 15. So my nitrides bring a grand total of -6 for the anions. Chromium, in Roman numeral land, is atomic number 24, a transition metal. They must add up to a +6. There are 3, so the charge on the chromium ion must be 2. My name then is chromium, Roman numeral 2, nitride. Let's give you one last one. Al2O3. Take a moment, attempt to write the correct name. Okay, hope I didn't stump you. Correct answer is aluminum oxide, not aluminum Roman numeral 3 oxide. A reminder, aluminum is not a transition metal. It therefore does not need a Roman numeral. So just because we learn Roman numerals, don't go Roman numeral happy. A reminder, metals in groups 1 and 2, as well as aluminum, and then you're responsible for silver and zinc, will not use Roman numerals when being named. We'll end here. Our next lesson will deal with naming ionic compounds that contain polyatomic ions.